Hello, everybody again. Second time I've done this in a few minutes, but it is 8:11 p.m. Central Time on the 18th of April, 2021, Sunday night here in the United States. Hope you're doing well. I do have this Windows update thing that's still supposed to go again, another one, just like the other one. So if it messes with anything, I apologize, guys. Again, you know how it goes with the tech issues. Just really quick, again, look in the upper right-hand corner. We've got a beautiful scene on the lake. Beautiful sunset after a rainstorm here. And yeah, just a good way to start the update in general. So let's get a display capture turned on. So my last update 2 days ago, we were minus a little bit of activity. Now we have returned in earnest with multiple 5.0 earthquakes. You can see spread here from the Northwest Pacific down to the Southwest Pacific, down to the far South Pacific, to the Southeast Pacific, East Pacific, and far west all the way over into Europe and out towards Iceland on the Mid-Atlantic Ridge. It's a huge spread of fives, plus multiple deep earthquakes that have taken place. And if you're a new viewer, let me just quickly explain the earthquakes that are raised high off the globe. These are deep earthquakes down below the plate. And when these happen, we watch for shallower, larger earthquakes and big spreads to take place away from the deep earthquakes. And the reason I think that's happening, let me just show you. I show this in all my updates. What I think's going on down below the plate, concentric standing waves forming in on themselves, and they can't compress down into the magma too much down below the plate. And so then we get, whoa, what is this? What the heck was that? Never seen that before in my life. Trying to get a PIN number. Yeah, all right, yeah, okay, let me type that in. Okay, so anyway, we've got concentric standing waves forming in on each other, hammering into the underside of the plate, and then a spread taking place going throughout what in this tank is a tank in a laboratory, but the tank that I'm talking about is Mother Nature's wave tank, and that's the plate boundaries over here in the West Pacific. I think it's really weird I have the USGS site open, and that little trying to get my PIN number little thing pops up. I've never seen that before, but that I wouldn't be surprised they're trying to fish me. All right, anyway, let's get back to the plate boundary map from the USGS. We reference this all the time because these are the boundaries between the plates. Now you'll notice on my map we have arrows that dictate where we watch next. We watch for a flow, like I said, the hammering action to come in on the underside of the plate with the deep earthquakes. Now the color coding on these, the darker red they are, the older they are. They're 48 hours. And the younger earthquakes are marked in white, and what struck in the past 2 days, basically in between, marked in a pinkish color. So going from our deep earthquakes, which you can see are marked in a pink, dark pink color, almost 2 days ago, hammering down to New Zealand almost 2 days ago. Now filling in the middle point in between the two, right next to the catcher's mitt position at the thumb of the catcher's mitt east of the Bay of Plenty in New Zealand, 4.9 earthquake striking right that middle point. Now we go up here, it's a little hard to see, but the middle points were struck here where the rings overlap by mid-range 4s and out at the pinnacle tip of the plate boundary, which is a triangular shape out here next to Fiji. USGS doesn't have anything on there. This is reported from the Europeans here. And then over to the west, 4.7. So it's a 4.8 and a 4.7. Now, how are those two connected? They're not causing each other, but they're along this. The plate boundary that's not really shown on the USGS map too hard, but it connects down across Fiji, and you can see it marked out here in the Undersea Mount Ridge. Now, over to the west, we have another 4.8, and that 4.8 is filling in the middle point between the 4.6 to the west and all the way over here in the 4.7. So this 4.6 and 4.7 are like bookends on either side, and this is the middle point. Well, actually, this is the middle point, and we're right next to it, but where the two rings overlap right here, Mount Katovar has come back alive in the past day, 2 days, over here in the West Central Pacific. Mount Katovar had not erupted for over 1,000 years and then showed back up in 2018. I said last year about that volcano, man, I'm getting years confused, guys. It's been, it was 2018 when that happened. Anyway, over to the west, 5.4 marked in that pinkish color from my last update, and another 5.4 That was the topic of our discussion in the last update. So let's get those out of there and see what struck since. There we go. Now you can see it. So going out from the 5.4s, what do we have? Another 5.4. Well, in the middle of it, a 5.8. So really, we have 5.4, 5.3 to 5.4, and a 5.8 sandwiched in together on both sides of the plate boundary. And sorry guys, I almost just sneezed into the microphone. There's going to be a hell of an update tonight, apparently. Pin numbers, sneezes, oh man, it's good to be back. So over here at Taiwan, and now look where the earthquake struck. It struck right between where the two plate boundaries come together, and this goes up into Japan. Of course, you can see it on the screen. It's like a letter H shape here, right next to Tokyo. But let's get back and look at the quakes. So back in the west, northwest Pacific, it's 5.3 and 5.4 with another 5.8. Then we go over to the far west, and we have a 5.0 and a 5.2. Look where the 5.0 and 5.2 are, and we will compare to the plate boundary map. Look, again, the USGS doesn't have this other earthquake because it's older than 24 hours. We're looking at the USGS 24-hour feed on their website here, but 5 down here and 5 up here, both on the plate boundaries, and the spacing gets back to that wave tank that I showed you at the start of this update when it asked me for a pin number. Might do it again, who knows? Maybe it's just some weird new feature on Windows or something. But okay, so here's the wave tank. Equal spaced waves throughout the tank. Now, I want you to think of these like the 5s that we're looking at now. So 5.4, 5.4, 5.3, 5.3, and the spread goes out instead of an even wave tank in a laboratory. It follows these red lines. And it goes all the way around the planet that way, but the origin point, or the deep earthquake, origin points, plural, are the deep earthquakes. Now you'll also notice there's some open areas that need to be filled in. Well, we just go back 48 hours. Boom, they are filled in by the previous earthquakes that were the 5.4s. So really, the 5.4 struck, then these spread out and made that standing wave across, well, if you really look at it this way, it's across what, 3,000 miles? But these aren't directly connected to each other across this distance. They're actually across a huge mass of plate boundaries that go back down and around to the south. So they're not exactly parallel to each other, although they are on the map. They're really connected to each other, an equal spread going up towards Japan and equal spread going out towards Myanmar. That's where we are now. Now Japan, right on the coast of Fukushima, or right off the coast of Fukushima, 5.6. So wouldn't you say this 5.6 is about the same size as this 5.4 or 5.8? They're within a hair of a point of one another. So another earthquake, and the spacing is perfect if you look at the combined area here. Let's go back to the plate boundary map. This letter H shape next to Japan, coming up from the south and going up to the north. And it's sandwiched, the north spot off the coast of Fukushima, is sandwiched between the previous earthquakes that struck just several days ago. But to see it, I have to zoom in very close. There we are. And again, I don't know if we're going to see all of these. Yeah, we're not seeing all of them from... Again, the Europeans report 4.5 plus. USGS is hit or miss. Now, the spacing is perfect on this. We go up to the other 5 on the coast of Kamchatka, where Mount Shiveluch is erupting. And over to the east, we have Seismopochnoi, which is also erupting in the Aleutian Island chain. Now, these 4s, you'll notice, are right where the 5 rings overlap, aren't they? The 2 4s sandwiched in the middle. So think of these like, again, like bookends, and in between, we have 2 4s. But it's sandwiched out and gone over to the west. The energy will follow where the arrows go, which really the arrows are just mimicking where the craton boundaries are across Asia and Russia. So, again, recapping, look at the area that's moved in the last day. I mean, it really is a lot to see move like that, but that follows the solar storm, which gets into what causes the deep earthquakes, and then that gets into the core of the Earth and how it's tied to the poles. Now, I would like to bring up, and I don't have the study here on me, but maybe in the next week I'll try and dig it up. It's just somebody related to me, I read it, whatever. A polar hurricane of electrons. They call it electron hurricane of electron cascade. In all their diagrams, it says electron cascade up above the North Pole and down across the South Pole. And that they found, particularly above the North Pole, that there's an electron hurricane that happens, that the electron cascade gets taken down into the ground, they said. Well, the ground is a relative term, electrically speaking, for going down to the core of the Earth, electromagnetically speaking. And when you think about the amount of charge that comes in from the sun, and the amount of charged particles that cause air glow across 1/3 of the Earth for a day or 2 days as it bombards the upper ionosphere with all those charged particles, and they start to swirl and get taken into the North Pole, where do you think it goes? It goes down to the core, but that would mean the core is not exactly a solid ball of metal. It's not a battery. It's spinning and oscillating. It's most likely a plasma torch of some kind. Mother Nature's plasma torch, a ball of rotating, oscillating, hyper-spinning plasma that's fed by electric from the sun that goes down to the core of the Earth, and then they mistook that for a solid ball of metal, or very close to it, maybe not solid ball of metal, a molten solid ball of metal, that they mistook that solid because plasmas reflect radio waves and shock waves, seismic waves. Plasmas will reflect, like an electrical arc, will reflect an actual shock wave or a seismic wave. Boeing just patented it a few years ago as a device to reflect shock waves from explosions on Humvees and tanks using electrical arcs. It won't stop the physical shrapnel from flying at the tank and whatever, but it will stop the shock wave. Now, if it'll stop a shock wave, an electrical arc, then it'll stop a seismic wave. It'll reflect it like it's a solid. Now, that gets into what an ionospheric mirror is up in the upper ionosphere from like a place like HAARP up in Alaska. Let me just quickly explain. I know this gets all technical and stuff, but HAARP zaps the upper ionosphere using high frequency. And that creates an area that glows, that you can physically see glow in the upper ionosphere like the northern lights, but it's a smaller area, a few kilometers across. Now that glowing air glow is from stripped electrons zapping the upper ionosphere with high frequency, exciting the electrons just like a microwave will excite the food in your kitchen. The same principle applies, but it's over a bigger distance, and they're using high frequency to do that. And there's pictures of it from the U.S. Navy, for instance, of these giant balls of plasma, they call it, and it's like a ring or a sphere-like shape up in the upper ionosphere, and it glows. You can see it on night vision, for instance. So anyway, they use the high frequency to zap the upper ionosphere. It creates the air glow, which then vibrates in the upper atmosphere and creates low frequency, like a bass drum vibrating, like a giant bass drum speaker vibrating. But they're doing that with high frequency from the ground, beaming it up into the ionosphere to excite those electrons. Okay, well now that power that it takes to do that is billions of watts from HAARP, and they say it just gets absorbed into the atmosphere. The electromagnetic energy for that. Now, what they found is that when they pulse the ionosphere and they create their plasma bubble up there in the upper ionosphere, it actually resonates, creates VLF that travels, and the electromagnetism of that, the actual electric charge, goes into the electromagnetic bands of the Earth and gets taken all the way down to the South Pole, or, well, Southern Hemisphere, off the southeast coast of New Zealand, somewhere out here. And they put a buoy out here to detect the electromagnetic VLF, very low frequency, that was being picked up on the bands of the Earth's magnetic fields itself. And there's what's called a conjugate point down here off the coast of New Zealand, for instance, for Fairbanks, Alaska, all the way up here where HAARP is. And when they pulse the atmosphere up here, it creates an electromagnetic disturbance that goes all the way down here. Now, that's with a billion watts of energy from a small location on the ground from humans. Okay, now, I told you all that because when we get a solar storm and the charged particles build up across the whole northern third of the planet, it gets taken in, according to new studies, via an electromagnetic hurricane that goes down to the core of the Earth, guys. Ground. And the core of the Earth consumes that energy, and that feeds the plasma, electromagnetic plasma down in the core of the Earth, which scientists thought was a solid ball of metal because they bounce waves, or they look at seismic waves, and they can even use VLF now, but looking at seismic waves, how they pass through and bounce off of the core of the Earth. And it shows as a solid or a semi-solid to them, because up until the past 10, maybe 15 years, 20 years at the most, nobody knew about the plasma reflection capabilities of shock waves. It can reflect radio waves up in the atmosphere like a mirror. But it turns out electromagnetic arcs, basically lightning bolts, can reflect actual shock waves. And then that's what the core of the Earth is. So we get a reflection off it. That's actually spinning electromagnetic plasma. In my estimation, this is my idea on this, and I'm sure a couple other people are going to agree, and there's going to be a ton of other people who don't. But the earthquakes. Getting back to the quakes. The deep earthquakes pick up, and the spreads of large activity, larger than what's currently going on at any given time. When the bombarding of the sun takes place onto the upper ionosphere, within a day or two, we see that go down to the core of the Earth, come back up, and new earthquake swarm begins and spreads out across pretty much the whole affected areas or the areas connected to it. Pretty much the whole planet in that case. So deep earthquakes happen, then spreads of fives happen, and that's what we're talking about now. And we're at a definite increase from where we were, which was fours and a few fives. Now we're at fives and a bunch of upper fives. And the spread, again, gets back to this standing wave. And that gets into very low frequency, which the spacing on these quakes, and again, I'm not going to get down and measure it to the mile, but again, you can see it. You can see the spacing on this. And think of this like the fives in the tank, but this is very low frequency across thousands of miles, where the peak of the wave and the trough of the wave are 500 miles apart, let's just say. I'm just pulling that out of the air. You know, it could be 1,000 miles apart, could be 100 miles apart, but still, we're dealing with some kind of low frequency that spreads out across these red lines. And that low frequency spreads through these areas like it's a wave tank, and it drops off the earthquakes along the way. So it's not that one earthquake's causing the other in some kind of like chain reaction or domino effect going across the planet. It's that in a day's time, we see this happen like a wave spreading through a whole tank. And that they're all about the same size, wouldn't you say? With the biggest in the middle, where the hammering's coming up and spreading out. Same with down here. Biggest in the middle, where the hammering's coming up and spreading out. So let's get into Europe. Check it out. First of all, we're quiet in North Afghanistan, Pakistan, China. This is the border of China. This is the Taklamakan Desert. I would expect a new earthquake right here in the middle, guys, or very close to it. Could be North India. We have Nepal, North India, North Pakistan, Eastern Afghanistan, Western China. You see where the arrows come in here. This is the Taklamakan Desert. So I'm going to watch right in the middle. And on one side, we've got upper 5, which we'll get into in a second. On the other side, we got 5.2. We put them together, we get near 6. So I'd put it at upper 5 at least, going in, or somewhere in that range, right here in the middle in the next few days. Okay? Now let's talk about Iran. First of all, we warned Iran. So I don't know how many viewers I've got in Iran. I don't know if they're friendly to people from my area or not. Salam to everybody, guys. Word up and much love, as we say here in the Midwest. But 5.8, man, I warned for a 6. There it is. It's a 5.8 plus a bunch of 4s and a 5. So if we take it all and add it together, it equals 5.9 to 6.0. Now let me show you where it really struck. Again, we've got it right on the arrow, but I want to go back to the USGS map over here. You see them all stacked right here. It's on the red line again. When I warned Iran, and I warned right in here, the reason we warned is because, well, let's go back to the start of the week. There's our red-colored earthquakes. So the red-colored earthquake struck at the start of the week, and this was the open halfway point between the earthquakes over in Europe and the earthquakes that you see red here on the screen right now. Again, the halfway point. You notice how it's the halfway point between the two sets of red? But it's not a perfect straight line, is it? Let's go back over and look. Mother Nature. Again, we don't have perfect straight lines in Mother Nature. We don't have a perfect wave tank. So, in other words, we had earthquakes over here in Turkey, and we had earthquakes over here, and this was the halfway point, down on South Iran on the plate boundary. And I told you guys, again, you can go back and watch my update from 2 days ago, that the combined total of what was between the two would strike with something bigger in the middle. There it is. Okay? Now, over to the west, check it out. Black Sea started to move over here with a 4. It's pretty low. Again, that's just nothing to really huge to talk about, but the location, the halfway point between the 5s. If we go up and around the bend of the plate, let's go up through the Black Sea on the USGS map. Go up, and here's the Black Sea, and around and down. And that's the halfway point. It's the halfway point between the previous earthquakes, too. I mean, you can see it. It goes up and around. Again, if this was a 2-arm scale where this was the balance point, this would be the middle point, wouldn't it? If it was a bell shape like that. The balance point, or the 2-arm scale. If it came up to a bell point, that's it, right there. Now, over to the west, same principle as the rest of the planet applies. We're dealing with the same sized earthquake spread out across a distance of a few thousand miles, but we're going from the Adriatic Sea all the way down to the South Mediterranean, going right north of Libya? I'm guessing. That's a total guess. Let's go see. I just gotta see. Ah, yes. Yes. Like Napoleon Dynamite crossed with Rain Man. I'm excited about these things. Okay, anyway. We're north of Libya with a 4.2 from several days ago, but in the past few days, take a look. Nada. We've gone quiet across North Africa. Meanwhile, we started to move in central Italy, right next to Norcia, but it's just a 3. But now we have a halfway point where all the rings overlap. Look where they overlap. Montenegro. South Italy, Montenegro, Albania. I'll warn right here where they all overlap. So really, we have to warn everybody from eastern South Italy all the way over into eastern Albania and Montenegro, Bosnia, and so forth. Again, where all the rings overlap. And we'll watch there for something near 5.0. Now, I said I was going to get into this one, right? We had warned, and last week, we warned right here. It got hit right next to it. That was last week. Now a new breakout next to Rhodes. Let's go back to the plate boundary again from the USGS. USGS plate boundary map really comes in handy, guys. They don't have to have the arrows on there. They said there was no transfer. That's fine. I'm showing you guys the transfer. They said there was none. Of course they're not going to have arrows on there. But you can watch it happen yourself. So look at the earthquakes going across from that we just talked about. And they dead end right here at the Aegean. Nothing large beyond the Aegean until we get out to the Mid-Atlantic Ridge. I'll talk about that in a second. So we have a halfway point of halfway points. We have actually 3 halfway points in between our current sets of quakes. So the first one I already told you about, right here. Again, we have all the rings, they overlap there. It's pretty easy to see. We have a 3 out in front of it, 5's back behind it. That means a 5 or something larger, but something in the 5 range should strike there. Now, the other halfway point is kind of hard to see. It's up here right at the conjuncture point between, well, actually, that's south of Istanbul, isn't it? Okay, so south of Istanbul, out here in the North Aegean Sea, that's our second warned area. I'll tell you about the magnitudes in a second. Third warned area is, again, where all the rings overlap in eastern Turkey. We should see a flurry of 5s. So I already told you about the one. It should be in the 5 range. The other one should be bigger, should be in the upper 5 range. Don't fault me, no pun intended, if it comes in at an upper 5 to 6. If that's what I'm looking for back here, that's what I'm looking for out in front. It's the same size going all the way around the planet. Now let's get into this. Look, I'm not exactly on the spot at Iceland. I'm just south of Iceland on the Mid-Atlantic Ridge. Going back to the USGS map, let's go out here and show you where we are. There we go. There's the earthquake right there. Now, we had warned Iceland. I'll consider this a hit, even though it's over 200 miles. And the reason I consider that a hit, it's a flare back up. You had a 4 out there, and now you have a 5. Energy flows around Europe just like it flows around all the other plates, and it tries to go out and equalize. Now, we're equalizing from all the way over here. So it's spreading up to Japan, out across, over to Europe, and trying to equalize on the opposite side of the planet. Once it gets over here, here's the Mid-Atlantic Ridge. It starts all the way up here at the North Pole at the supervolcano. 60-mile long, 30-mile wide caldera down below the North Pole. And the Mid-Atlantic Ridge, everybody knows about it, at least you've heard about it, goes down through Iceland, through the center of Iceland, and you can just follow it like a break across the whole planet, all the way down to the South Pole. Okay, That's like a wall for this energy to try to pass beyond. So everywhere else around the planet, you have flow points. So if you hammer in here, it kind of goes over and flows like a river over into these juncture points going up into Japan. Then it flows again like a river and goes around. It's pretty smooth. Once we get up here into Asia, we go across the Himalayan range. But again, the flow is pretty smooth. Once we get here, we have a dividing line. You see, it goes north and south, and it's a fracture zone. This is where two plates come in together. North American Laurentia, Europe and Asia, and the Mid-Atlantic Ridge, of course. So you see how, again, it goes all the way down to the south. When energy is flowing across here, once it hits here, it goes back into the planet. And if it's a big enough push, it comes back out the antipode, the opposite side, with new deep earthquakes. So now, wait a second. The antipode for that brings us in all the way down here, down in Antarctica, where I don't think we're going to ever get any earthquakes ever reported anyway. So I don't think we get the earthquakes reported in Antarctica. However, the antipode for New Zealand and the Kermadec Islands is Italy and South Europe. So if we start to see new deep earthquakes down here, I know that a few days before, all I have to do is go back and look back at the feeds, and I'll have seen an earthquake swarm go in up here. When the push is, think of this like a audio system. You ever hear somebody talking to a microphone at a concert, and you get feedback and it starts to squeal? And feedback can be something that musicians use, like Jimi Hendrix. They use the feedback of the guitar when they get the guitar's magnetic field close, and it picks it up audio, and it takes it back through the system at the speed of light, basically, at the speed of electricity. Spits it back out, and the audio is still going from the previous round, if you will, of electromagnetism going through the guitar. And it starts a feedback loop, and it'll get louder and louder and louder and louder until the speaker breaks, or until you pull the source back. Now, a feedback loop can happen in many things. In audio, it can happen in electricity, it can happen in electrical systems, it can also happen. And in this case, the feedback loop is seismic, but it's got to be electromagnetic. I've already talked about that a whole bunch in this update. So when it comes back through, it hammers back through again with new deep earthquakes, and the cycle starts over. And if there's enough of a push, it can have a crescendo effect where we get a big break that happens as a result of this feedback loop that goes through the planet, the planetary-wide feedback loop that takes place. Do you follow me on that? Okay. All right. So let's recap. Deep earthquakes came up a few days ago. Spreads went down to New Zealand, 5.0. Spreads went across over to Western Indonesia with up to 5.4. Then we spread over the last day and a half with another set of 5.3s and 5.4s, with the biggest in the bunch combining with 5.8. Then that 5.8's energy spread around the same time, up off the coast of Japan, we get a 5.6. Not much loss of energy. Once we get up to the north, we get a 5 off the coast of Kamchatka, and at the middle points, we got 4s filling in those middle points, the standing wave spreading out across the whole areas. Check off Myanmar, if you were watching areas that were middle points getting hit. Check off Iran, if you were watching areas getting hit. Check off the Aegean Sea if you were watching areas getting hit. And check off Iceland if you were watching areas getting hit, as the energy was spreading across the plate. South America, same size, guys. 5, 5.1, 4.9, and it's north of the tip of Antarctica meeting into South America. Oh, guess what's there? You guessed it, if you are a guessing person. The red line again. Plate boundary. So the plate boundary is being hit on all sides of the Pacific and the adjacent plates that it connects to. Again, we just went over to Europe all the way across, and now we're going all the way across the opposite way. But again, it's trying to equalize across the whole mass. It also went up to Japan that way. So here we are in the Southeast Pacific, and here we are with R5 going over towards the Pinnacle tip, which is all the way out here at the South Sandwich Islands. That's the next spot to watch. Over to the east, we have a 5 coming in from the north and a 5 coming in from the south. We have a combined point right here, tip of the plate boundary down at the South Sandwich, all the way down here where my mouse is, down in the lower right-hand corner of the plate. So, getting back to it, it's a spread. It's the same size. Again, 5s on one side, 5s on the other, and of course, next to the deep earthquakes. That's where the biggest of the bunch are taking place, recombining and spreading. Central America and northern South America, you'll notice we have a huge open area. This leads me nicely into the Volcanic Ash Advisory Center. Man, tonight's update is info-packed, isn't it? Let's carry on and go look. Volcanic Ash Advisory Center. Dukono in Indonesia. La Soufriere in St. Vincent. Still going, but it's kind of calming down from where it was. It went up to, I think, 20. There's media reports of 20,000 foot eye blast, but you guys all saw the report. It went up to FL350, which is 35,000 foot. Soufriere again. Popocatépetl in Mexico. It's a regular eruptor. Sabancaya in Peru. Same thing. Normally on the list. Sanjay in Ecuador. It's been on the list for the last year and a half. You know, there were years where it wasn't, but it's on there. Sakurajima in South Japan, that's a normal eruptor as well. Sometimes I have a video from 2015 where it erupted 85 times in one day. And I got every shot of it and time-lapse sped it up. You can watch it. It's still on my YouTube channel. Popocatépetl again. Sinabung, 10,000 foot high blast over in western Indonesia. Luitolo. I had to go look that up. You guys remember I didn't know where that one was, but now I do. Fuego in Guatemala. That's in Central America. And Seismopochnoi I mentioned already in the update. And that gets us into yesterday and the day before, which was Mount Chivaluche as well. Let's get in and show you where these all are. We'll start right at the center of the screen. Mount Sanjay and Mount Reventador both going right here in Ecuador. We go to the north and we actually go over to the Eastern Caribbean, where St. Vincent La Soufriere is erupting. We go over here to the west and we have Mount Fuego, and Pacaya was erupting last week, but Fuego's going now, and Popocatépetl is erupting right here. Down to the south, we have Sabancaya erupting right here. So hold on, let's just show you where these are at a greater level. Mexico, Guatemala, going over to the Eastern Caribbean, down here to Ecuador, and down here to South Peru. Look at the spacing on that, on the volcanoes now. Here, 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 and here. And compare to the plate boundaries. And I would say to you that that's a semi-equal spread of eruptions. Up here in Mexico, next to Mexico City. Down here at Guatemala. Over here at the Eastern Caribbean. Down in Ecuador. Down in Peru, and that's a spread across all of the area, volcanically speaking. That all the volcanoes equally spread, somewhat equally spread. Now the earthquakes are doing the same thing that we see go all the way around the planet, but it's much, much less right now. We're at the 4.0 level off the coast of Central America. We're at the 4.0 level off the coast of Alaska. We're at the 3.0 level in the United States and in Hawaii. So clearly this area, Central America, Northwest Pacific, or North Pacific, and Hawaii, Central Pacific, quiet. Well, quieter. A whole magnitude quieter. But look at this area, what's protecting it. Or I shouldn't say protecting it, what's around it. We'll start down here in South Peru, where the volcano is erupting and the two earthquakes are. Now notice, just north of it, there's like a crescent C shape of undersea mount volcanoes that comes down and goes back up to the north, and we can follow it, and we carry on and go up to the north. We go past Tamu Massif, the largest undersea mount volcano, I think, or it might be one of the largest, this thing right here. But we connect into the Hawaiian Island chain with this undersea mount chain. And the Hawaiian Island chain branches off and goes out here into the middle of this fracture zone. Do you see the fracture zones here? They're somewhat equally spaced, going across the whole Eastern Pacific. But you'll notice the fracture zones come back to this undersea mount chain, don't they? And they pretty much dead end into it. There's only a few spots where the fracture zones come through. And where the fracture zones come through, they go back to where the deep earthquakes are, right there. Now going up to the north, like I said, we go all the way up into the Hawaiian Island chain and it connects into, well, really Alaska and Kamchatka, doesn't it? So now hold on. Everywhere from up here to the north, going down to the south, following down and around, going over into Peru. It's not like it's a dome of protection, but we see the earthquakes get to this point, and once they get to here, we take a step down by a magnitude, usually. Now, eventually it equalizes, but it takes a few days of earthquakes spreading across the energy. I think of it like this. The standing wave is spreading across those plate boundaries. And the easier of a curvature for it to pass through on the red lines here, the easier of the curvature, that enables the flow to increase and go across the area, or not increase, but definitely to maintain at least. And when we get to a steep curve in the plate where it has to go around a steep bend, it takes a step down. But where it takes the step down, we get eruptions, we get big earthquakes. And that's where we are right now. You can see it's all the way up here to the Kamchatka Peninsula. Seismopochnoi is right here in the middle, in between where the 5 is, and all these earthquakes are going over to the east. Where the rings overlap, that's where Seismopochnoi pretty much is. So how does that play into Central America? Well, again, we're 1 magnitude lower in Central America because the energy that's going up and around and the energy that's coming across to South America clearly has not reached Central America yet. It's a pretty basic 101. Why isn't it moving? Well, it hasn't reached there yet. But you can watch it creep over and come over, so I would look now, within the next few days, right here in central Mexico. Now, look at the middle point between our earthquakes in the United States and the earthquakes down right here in the middle of Central America. Where the rings overlap, that's where the 2 volcanoes, Pacaya and Fuego, are. And look on the USGS map here. So it's pretty obvious that's where the red lines come together, aren't they? Don't they? And over to the east, that's where La Soufriere is erupting, or in the eastern pinnacle. Man, hold on. I gotta sneeze, hold on. Oh, man. Dude. Oh. All right. Sorry. Hey, it is what it is. It's springtime. So over on the Eastern Caribbean, weatherman, hold on, Hachoo! You'll never see that on the nightly news. That's okay. I'm not professional. Over on the eastern side, we have an eruption. On the western side, we have an eruption, like bookends of eruptions. Now, isn't it just too odd that right in between our 2 sets of eruptions, over here and over here, right next to this stair step of the fracture zone, that's... Oh, thank you, babe. Thank you so much. Thank you. She brought me an apple juice, guys. I'm sipping on... Actually, I'm sipping on coffee at 8:49 p.m. Shame. Don't drink coffee at night, guys. You'll turn into me. I don't know if that's a good thing or a bad thing. Okay, one more time. East side of the Caribbean, volcanic eruption, La Soufriere. West side of the Caribbean, over where the red line comes into Guatemala, eruptions. Right in the middle, that's where the mystery earthquake happened. The mistake quake. The misquake. The one that I issued the forecast for. The one that I said watch out for a 5 to near 6.0, and a 6 gets reported by the computer, and the professionals weigh in and say, oh, it must just be a mistake. Okay, I just have to point that out. That happened. Again. For the 18th time. Yes, 18 times. Okay, all the way up to the North Pacific we go. Alaska. So to see this, we actually need to turn down the rings so we can just see where the earthquakes are. And we have a pretty uniform line of quakes, like I said, going up to Kamchatka. Once we get over here, we take a magnitude step down to 4. Got to remember there's a volcano erupting up here that doesn't normally erupt. That's Seismopochnoi. Seismopochnoi, my friend. Нет. Здравствуйте, как вы, позовите меня зовут Mikhail Ильич, Seismopochnoi. I took Russian in high school, guys. Come on, man. You know, you have a chance to take Spanish. You have a chance to take French. Who else would choose Russian? Come on. Oh, my middle name's Yuri? Oh, that doesn't help. I swear. My parents cursed me. Okay, going across from Seismopochnoi that erupted, we have a 4. And then it's like a ramp of earthquakes jumping up off the plate boundary and going and dead ending right into the highest point in North America. But really, I want you to think of these coming up underneath the highest point in North America. Again, the higher they are off the globe, the deeper they are into the earth. And so we have a hammering action coming in, but this is all small earthquake activity. But look, coming in on the north side, going up to the north, jumping off like a ramp, and we go into the edge of the North American Craton. Yes, that's right, the North American Craton. And the Craton, I want you to remember this as just the interior portion of the plate versus the exterior portion of the plate. In North America's case, we have this diagram here. Every plate is made up of different cratons, some plural, some singular. But the faults, these thin red lines, the thin red lines are faults. The thick red lines are plate boundaries. What's the difference? Well, to me, the difference is a fault is a crack in the plate, somewhere from the surface going down somewhere into it, or in the middle of it, or at the bottom of it. A plate boundary is a crack that technically starts at the surface and goes all the way down, not perfectly straight up and down vertically, but nonetheless, it goes all the way down between the two plates where they meet, down to the bottom of the plate. So it's a crack that goes all the way through the plate. The difference between the thick red lines and the thin red lines, to me. And this energy that's coming up from down below the plates, down below, and again, where all the deep earthquakes are hammering, all the way over here in the West Pacific, that's coming up from down below the plates. So when it comes up to the underside of the plate, the first thing it hits are these weak points, which are the plate boundaries themselves. The energy travels up and around, and then it goes into the plates. The plates absorb the energy off the thick red line, and then it goes through the plate and tries to equalize across the plate. Just like it's trying to equalize across the thick red lines around the planet, it goes into a plate, absorbs, and goes across the plate. So, earthquakes come in off of Alaska and hammer into Mount Denali. Now we're going to get over to good old Google Earth and go take a look. Mount Denali. It's Mount McKinley. Y'all, it's Mount McKinley. It's not Mount Denali. No, okay, I don't want to get into that debate. Google Earth has it marked as Mount McKinley. Oh my gosh. No. Oh, okay. Hey, it is what it is, guys. So, Mount McKinley, the highest point in North America, looks over, again, the north part of Alaska. I mean, it really is the highest point in all of North America. Think of it as energy coming in on the underside of the plate, pushing it up. And there's a steep curvature of the plate boundary that goes down to the south, out in the ocean. But the interior portion of the plate is what we're concerned about now, because we're absorbing energy, taking it into the plate and taking it across the United States. And the thin red lines come into play then, the faults, the breaks in the plate, because the plate's being inundated with pressure, of course, or power, or some kind of inundating wave, getting back to the video I showed you at the start. Some kind of inundating VLF, very low frequency, electromagnetic of some kind, maybe. Many possibilities on that. But it flows down into the United States, gets absorbed by the North American Craton, and we see earthquakes break out in equal spacing, just like the rest of the planet, go across all of North America. The good news for us in North America is we're the last on the list. The energy goes path of least resistance, from where the deep earthquakes are, straight out and away to the west, straight out and away to the east, straight out and away to the south. And it goes around and up to the north. But like I said, it hits that pinnacle point, that bend point at Kamchatka, and then it has to come over, around, and down, so to speak. Not down, but over, around, and over. Down is just a southern term, okay? We're going south when I say down, all right? Down always feels like south, doesn't it? Okay. So going across North America, we'll get into Hawaii pretty much last, coming out of Alaska. So we have fours coming in. That means fours coming into North America. If there's fours up in Alaska, you can certainly expect fours to come down into the U.S. We're one step away from it already. We're at threes. Now look at the Craton diagram. One more time. I'm going to show it a bunch more times, but look at it one more time and compare it to the earthquakes in the United States. Do you notice anything? Well, I mean, it's pretty obvious. The earthquakes are going right down across the edge of the Craton, down through Texas, back up through Oklahoma, over to the New Madrid seismic zone in southern Missouri. I live just north of here, guys. Hey, I live just north of where the rings overlap. Uh-oh. Over to the east, we have an earthquake all the way up in New Brunswick, Canada, eh? But down to the... come on, I can crack those jokes. My Canadian viewers love me. They break open emulsions every time they hear my voice. So down here to the south, we have a line of earthquakes. They're all zeros, ones, twos, and up here we have a 2. So it's 2.1 and 2.1 to 2.2. There's a middle point in between these sets of quakes, and I had a warned area in Virginia. We warned right here in Virginia. We still have not seen the earthquake. I'm going to have to adjust the warned area now. We have to take it right into the middle. So in the middle, we have Pennsylvania, we have New York. I'll warn both. And we'll warn over on the western side, over by Lake Erie, which is really Craton Edge. So I have to adjust it one state to the north. I warned Virginia. We have to move it. The earthquake struck just a little bit to the north. So the new halfway point between the two, if we go up along the edge of the Craton, again, it's perfect halfway point right there in the middle. All the other middle points should be hit as well. So we're about to see several more earthquakes strike across the United States. We'll get over on the west coast and start up in Washington. Washington? Washington. Okay, we're in Washington. And we have an earthquake right to the east-southeast side of Seattle. This is on what's called the Seattle Fault. And let me take it down to zeros so we can get everything. The Seattle Fault is the main mover right now, and it pretty much always is. Around it, just to the south, we have Mount Rainier. But I'm more concerned with the lone earthquake about the same size, all the way over here to the east. We see an earthquake at Mount Rainier, it doesn't mean it's going to erupt. It's just a sign of a little bit of perturbance at the magma chamber. But what's going on over on land, over here at Desert Air, Washington? Man, guys, Desert Air, we're back there again. I hate to have to do this because I love Washington, first of all. We went up there to take the radiation readings after Fukushima happened 10 years ago. 2011, my young YouTube channel, my wife and I got in our car and we drove all the way from St. Louis, Missouri, all the way up to the Washington State coastline, and we took radiation readings along the way because the U.S. government turned off the radiation monitoring stations from the EPA. Now, it's ironic that I'm talking about Washington and radiation in 2011 because look where we are. We're at the Hanford Nuclear Waste Storage Facility. Now, they used to have old reactors placed along the river here. They broke those down, left the caskets, took all the radioactive material, and put them into storage containers here. And they put them into train cars, uranium millings into train cars, and then put them into tunnels in the ground. Now, a few years ago, earthquake struck around the outside edge of here. Actually, they struck right where we are right now, actually. Series of small earthquakes start to strike there, and I made videos talking about it. People said it didn't really mean anything, and nobody paid attention. Within a few weeks, there was a tunnel collapse here that opened up the surface, and the tunnel collapsed, and it exposed these train cars that had uncovered powderized uranium millings in the train car. The wind blew in, and they had to evacuate the facility and go in and clean it up, and I don't know where they are with that now, but that was several years ago. Now, there's also something else here, the LIGO Gravity Wave Sensing Station. This thing is a series of long lasers and these tunnels that bounce back and forth on these little mirrors at the end and reflect back, and they show vibration of the lasers, and they detect what's called gravity waves that come across the universe. But I think it's really weird they have it pointed at a right angle, right at the heaviest elements known to man on the periodic chart. It must just be chance or coincidence, no biggie. How about the earthquake next to you? You think that's chance? Let me tell you another story. Series of earthquakes broke out here 2 years ago, right? Yeah, 2 years ago. And they broke out around going up to here. So it was Beverly back down and around. I started to document the earthquakes again. I brought up the story of the tunnel collapse the last 2 years ago. Fires broke out here. On a clear day, they blamed it on, what did they blame it on, guys? Do you guys remember? Was that the motorcycle wheel? The flaming motorcycle wheel? Or was it the dump truck? I don't remember what they blamed it on, but we had the earthquakes there, and then the fires broke out there. We've also seen what we see are called hot spots that show up around these areas, these little red dots that the satellite identifies as heated areas like this right here, for instance, or these little red dots across the map on the screen now. So these hotspots showed up around where the earthquakes were. We saw fires break out next to where the hotspots and earthquakes were. We saw the tunnel collapse next to where the earthquakes were. And it all took place right around here right around the Hanford Nuclear Waste Storage Facility, LIGO Gravity Wave Sensing Station, and and something else. They call it Gravity Hill that's right here, and it's like apparently a road where your car rolls uphill, or it looks like it. It's an optical illusion. All right, why am I bringing all that up? The earthquake that's there. Got to pay attention to it, even though it's small. If I see any more there, I'm going to keep making documentation on it. And if anything happens there, we'll know to relate them to the earthquakes, whatever happens. Now, Mount Rainier, 0.6, it's the same size earthquake over at the volcano. Seattle fault, like I said. Now, let's go back over to the USGS map. This is going to all make sense in like 2 seconds. So, I already talked about Alaska, the flow coming in from Alaska, jumping off the ramp up into the little thin red lines, which are really just the interior portions of the Craton edge. The green versus the purple and brown. Now this comes down into the northwest, and out in the ocean, we have the Juan de Fuca fracture zone. Come on, everybody, say it after me. Juan de Fuca fracture zone. You'll always remember it after. You have to say it like that, too. Put some bellow in your voice, guys. Get some air in it. Juan de Fuca fracture zone. Out here in the ocean, and it looks like a letter M shape, and these are all like little arrows pointing into spots on land. And the reason I call them arrows pointing into the land, even though they're just jagged edges that belong to the Pacific Plate, these jagged edges belong to the Pacific Plate, like a giant saw cutting into North America. But there's something related to these triangular points that we have to go look at a different map on. USGS doesn't show these. We have to go to the Pacific Northwest Seismic Network. Now, the Pacific Northwest Seismic Network provides tremor data. These are small vibrations as the plate shifts. Now, they do assign magnitudes to them, you see on the right-hand side. But think of these more like I said, vibrations as the plate is shifting. I don't really think there's very much cracking going on in the plate, like a fault, a break in the plate. It's more the whole area there, 100 miles across, is shifting all at once with thousands of small little vibrations. Okay, that's how I want you to think of them. And look where they are. They're in Portland, Salem, Southwest Oregon, going into Northern California, right at the border. Now, this is the 18th. This is today. We have 563. Wow, that's an actual increase from where we were. Let's go back to the 17th. 758. Well, that's an increase from where we were. I haven't checked in 2 days. 2 days ago, we were at 200 range. So 2 days ago, in my last update, this is where we were. Medford had a little cluster, Salem had a cluster, and a little cluster right up here in the Strait of Juan de Fuca going down into the Puget Sound. Actually, that's the Puget Sound. So then, in my day off, we went from 244 up to 758. And the area, as I talked about in my last video, that it spread to, it had gone up previously up to Vancouver Island. So the area that it spread to, the number went down. The number of little red dots on the screen here, they went down as it spread out. So the number of little vibrations went down, but the area increased. And then I go away for a day, and the area that it spread out to, then it increased with the number of earthquake tremors. Tremors, not quakes. Earthquake tremors. Whatever. On the western coast of Oregon, here we are today, and we are shifting still, but I mentioned those triangular points out in the ocean. Those triangular points out in the ocean correspond to points on land that are shifting, like arrows pointing in. But we have to go to Google Earth now and look along the coast and look at an angle, because really the energy is coming in from the underside of the plate, guys. So I already told you, it's coming in from Alaska, it's coming down from the north on the edge of the Craton. But then it comes in from the underside. Oh, well, too many place marks. Oh my gosh. There, okay. So coming in on the underside of this, going into the underside of the plate, and then it flows down across North America, following the Craton edge. But these triangular points point right into the spots that are shifting up above them. This is down below, this is up above. So pushing up in. Now getting to the rest of the quakes. Going over to Idaho, going over to Montana. In my last update, I said Montana twice when I meant Wyoming. I am so sorry, guys. This is Wyoming, by the way. This is Montana. But I was really just referring to the edge of the Craton. I was looking on the edge of the Craton in Montana and Wyoming. Now, Yellowstone. The famous supervolcano everybody knows about is right here, center of the screen, right at the border of Wyoming, Idaho, and Montana. Now, is it any coincidence Yellowstone's on the direct edge of the craton? The rusty brownish color versus the purple? Now, if you go over to the west, the purple color goes over to California, right at the California-Nevada border, doesn't it? And guess what's at the California-Nevada border? On the other side of the purple. Another supervolcano, Long Valley Caldera. So right here, where all these clusters of earthquakes are, there's a supervolcano, Long Valley Caldera. Let me show it to you. Most people don't know about the California supervolcano here. This is Long Valley. Let me turn on the place marks from the Smithsonian so we can just, again, show the new people, in case you don't know about it. 1,000 cubic kilometers of melt down below, defining it as a supervolcano. And again, if you need to read it, you can pause it and read it on Long Valley. So the earthquakes start inside the caldera for the supervolcano. They go across the border all the way over to here, to Monte Cristo Hills volcanic buttes. So Monte Cristo Hills back to the supervolcano. And let's go compare the quakes. There they are. Now you'll see there's a spread, just a 1 up to the north, a 1 over to the west, and another 1, 1.9, all the way over on the far western side. What's up at this one? On the Nevada side? Well, there's a place called Mud Springs Volcanic Buttes. The earthquake brings us in here just north of Mono Lake. There's Mono Lake, I used to call it, but it turns out it's Mono. I can't. Okay. And up here, Mud Springs Volcanic Butte. And this thing's pretty impressive looking. It's 300 feet high off the desert floor. Old lava flow. And there's the sill for it and the old spatter cone. And on the other end of it, there's the lava flow, how it's spread out. But 300 feet high. Think about the lava flow over in Iceland a few years ago with the Bardarbunga volcano. It was like 20 or 30 feet high, rolling across the landscape. Pretty impressive looking. 300 feet at Mud Springs. Aurora Bodhi Crater is the actual marked Smithsonian here, and it had a more viscous, chunky blowout here. So it did blow out in the past, but look at the flow on that. So it just looks like it went gunk out, and that was it. But both of these are on the side of Mono Lake, which is really on the side of the supervolcano. And they're all connected with quakes right across the middle of it. Over on the western side, what's over here? Well, this is pretty interesting, the 1.9. Mid-Pines, California. 29-kilometer depth. We aren't normally over here in the eastern side of the valley, guys. So let's go see what's going on. We're back at a hotspot location, back from forever ago, back in September of this past year, I think. Yeah. No. Wait. Nope. Today. Hotspot today, California, right next to the earthquake location. What did the computer detect this as? It said it wasn't a fire. It doesn't know what to make of it. The computer, again, we're talking about a weather satellite that's designed to pick up fires and wildfires, but it's detecting these, and it doesn't know what they are. So it filters them out. We get them still. We can see the whole unfiltered feed, but the general public would go look at the weather feed, and they wouldn't show anything because the computer's saying it doesn't know what it is. Well, look, we got an earthquake there, and we have a hotspot there. This is like the thousandth time, if I could say it proper, 1,000th time that's happened. Look at how many are down south. Are these all today? They certainly are all today. And I guarantee you they're not doing massive burnings across California right now. And again, I mean, they're just not going to do it. There's the ones from September last year. So these are all current. In the last day, we have another one out here in the desert in Death Valley. Now, that's coming from a watershed in the springtime. A hot spot in the middle of the desert in a watershed next to Ubehebe Craters. And Ubehebe Craters has been a topic of discussion in my videos for years. And the reason we talked about it in the past is because the earthquakes were striking here. Now, I would like to point out that for the last 9 years, oh my God, it's been that long, dude. Oh my God, 9 years. 9 years. Started showing this volcano 9 years ago. And people said I was a fearmonger, right? They said there was no relation between the earthquakes and Ubehebe Craters, even though they were happening right next to them, right around here. Now, in the past 2 years, the USGS has come in and actually changed the threat level at several volcanoes across California. They raised the alert level slightly at each, well, not each, at several volcanoes. Guess who they included? That's right, UBB craters. All of a sudden, they put them on the list. So, next to it, we've got a hot spot out here in literally what would be right now, I think, starting to fill with water in the springtime. It's just not a spot where you would get a big fire. And to put it in perspective, a 5-acre fire did not show up next to my house on the satellite. Look how many there are, and look how widespread this is. Look at Mexico. Now look, I've never seen anything like this in the times that I've been looking. No one can tell me that this is a chance or a coincidence when it's matching perfectly with the regular edge of the North American craton. And it's a perfect match all the way down to where the satellite coverage cuts off. I have never seen that many. And the spread is insane. Now we're going across all of southern Arizona, southwest New Mexico, all of western Mexico, and the computer is filtering, I'm thinking, each one out. Hold on. Yeah, the computer is filtering out every single one of these and saying they're not fires at all. So nobody can tell me it's a farmer burning their field, for instance, right? Those days are over. The computer's saying it's nothing at all. Just a mistake. Okay. So nobody can tell me it's a farmer burning their field in the middle of the desert at night. And nobody can tell me it's a fire when the computer's saying it's not. What does it all mean? Well, the plate shifting. Let's get back into it. Sorry, I get a little mind blown when I see that amount of going on. That means we're looking at earthquakes. Hey, hold on a second. Didn't I just warn right here? I sure did. Start of the update, I warned right here. Pinnacle tip of Mexico, going out along the plate boundary is a spot to watch for seismic activity. And look where the hotspots are going down towards. Now, of course, we can't see them all the way, but I'm going to tell you, they carry on all the way down here. Something's causing some kind of electromagnetic heating, which the computer up in space, trying to read for fires, is detecting as a fire, but it's filtering out because it's not. So the plate's moving. We know the plate's moving. Look at the rest of the earthquakes going all the way over to the East Coast, going back down across Texas, Oklahoma, and going back up to the Northwest, up to Washington, where we're having hundreds and hundreds of tremors now as the plate is shifting across Washington and Oregon. So when the plate shifts in Washington and Oregon, we see earthquake spread over to Idaho, down across the plate down to Texas. We see earthquake spread down to California. Then we see a break happen, usually around the same time, out in the ocean, off the coast of where the area that's shifting. So a spread goes down to the south, spread goes over to the east, and a break happens out in the ocean where the whole thing's coming from. And we know where the whole thing's coming from, all those little red dots and the big arrows pointing into them. Well, two sets. I'm talking about two different sets of red dots now. Hold on. Oh, man. Hold on. Okay, these red dots are the tremors, and these red dots are the hot spots. Man, I'm going to have to get a new place mark for these things. Okay. All right. So the red dot tremors are a sign that the plate's shifting, and then after that, earthquakes spread down to the south to California and spread over to the east and down across the craton down to Texas. Now, do I need to show you all the drill points? The drill points across Texas and Oklahoma. All of these earthquakes in Texas and Oklahoma are at oil and gas well drill points, along the edge of the craton, of course. Now, I shouldn't have to waste your time looking them up. You guys can fact check me on that if you don't believe me. Go pull the coordinates from the USGS, look them up. It's not about belief on the way on this update or anything. I hate asking people to believe me online. I'll show you a couple, but if you want me to look them all up, that's just going to take too long. So I'll just show you what to look for, and then you can go look the rest up. So when you zoom in on an area, you'll see here's the earthquake epicenter, and right next to it, you'll see these little pads cut out of the ground. And we zoom in on the pad on the ground, and you're going to see there's tanks and pumps and jacks and pipelines. They even have a laid-out pipeline right there, and there's the spigot for the wellhead. So that's like, or the well apparatus right there. Some of these are saline ponds where they'll collect water. They'll collect this water and then take it and pump it down into the ground, mix it with toxic wastewater. They call that wastewater injection. It breaks apart the shale and releases more gas and oil. Now look how many there are, and you'll start to see that it's a real amount of perforation going on here on the edge of the plate, and each one of these is a shaft that goes maybe down a mile or two, who knows how far, and spreads out thousands of feet at least, each one. And you start doing this many on the edge of the craton, and the next thing you know, you're perforated and you get earthquakes that spread across the area. And that's over here on the western side of Texas. Every single other earthquake here, again, just like what I just showed you, are all directly next to drill points, going up into Oklahoma, every one of them, okay? But these, over here, these two aren't. I've got to show you these. We're going to start with this one. We're going to build our way up over to the New Mexico border, man. Oh, it puts a smile on my face to be able to talk about this one. So let's go look up this lesser one first in New Mexico, which in itself is pretty impressive. Look where we're going. So we're hardly ever in New Mexico, but hold on. Craton Edge, guys. Look where it goes. It goes out of Montana, goes down through Wyoming, across Yellowstone, down through Colorado, central Colorado, right along the Continental Divide. Goes down through southern Colorado, goes straight through central New Mexico. Down to Texas, makes a bend, doesn't it? So where are we? We're in central New Mexico, of course. And hitting search on the earthquake epicenter, you're going to notice there's some volcanic formations around us. Mesa Redonda Volcanic Butte just to the east by a couple miles. And Jordana del Muerto Volcano. Jordana del Muerto Volcanic Field, south central New Mexico, consists of a low shield that was the source of large radial lava flows. That's how you can see them on the ground there. The age of the lavas is 0.76 million years ago. Let's go look at these. Old lava flows. You know what? They're so old, they have no trees on them. That's how old they are. So old, you're not going to even get a tree. Ah, it's the desert, Dutch. It's the desert. Let me remind myself, talking to myself in the third person. I've got to get out of here. Mesa Redonda Volcanic Butte. This actually probably formed when this was all underwater. Again, 0.78 million years ago. The deposits of the sands there, we all know about that. But I want to talk about this one over here. Over at the border with Arizona and New Mexico. Franklin, Arizona. Man, do I have a story for you guys. So a 5.0 range earthquake struck down here a few years ago. And imagine our shock, right? Everybody sees it. A 5.0 range earthquake. Now look at all these hot spots that appear, by the way. So 5.0 range earthquake strikes. I make a video showing the location. Man, we got a hot spot right next to it in the desert. But I make a video showing the location of where the 5 is. And I zoom in on the area and I find this. Let me bring this at an angle. Okay. There we go. Now we can spin it around a little bit. Okay, you see that? Okay. So the earthquake struck pretty much right next to here. And I zoom in on it. And of course, I mean, you can see what it is. It's an ancient volcano. And I didn't know the name of it at the time. I didn't have the Smithsonian place marks for the updated Smithsonian place marks. So I make the video and show this and describe it. And of course, I put it out to the world. And a guy who claimed to be a paper reviewer for the American Geophysical Union. His name Ben something. Not the solar guy, not observers, a different Ben. But he ran a channel called Space Weather. So a different Ben runs a space channel, and he accused me of fraud. This professional guy. And he said there's no volcano there, and that I made it up to try to get views. Now, this is a guy who said he reviews papers for the American Geophysical Union. You can still find his videos on YouTube ripping me apart. Now, here's the problem for him. Smithsonian updated their place marks in the past year and a half. And you have to zoom in on it a little bit to see it, but you'll see Here's the volcano, and here's the Geronimo Volcanic Field. The Geronimo Volcanic Field consists of over 140 eruptive centers, mostly pyroclastic cones, which is what we were just looking at, by the way. In an area of 850 square kilometers. The basaltic field in the southeast corner of Arizona was active between 3.2 and 0.3 million years ago. Now, the guy from the American Geophysical Union never retracted his claims that I committed fraud for showing this and saying that it wasn't a volcano. He was wrong. It is. And it's part of the San Francisco Volcanic Field, and there was a 5 there. We have hotspots going on around it now, or not San Francisco, the Geronimo Volcanic Field. And long story short on it, guys, it gets hit with earthquakes as energy's coming across the plate. Rare, but it happens. Why? Why is it rare? Well, I think it's mainly centered around pushes coming into California. The more the plate shifts up here, the more it goes down to the south, the more it goes over to the east, the more it pushes on the southern edge of the craton, and right behind the southern edge of the craton, one more time, craton diagram, look on the west side of the rusty color, guys. That's where the volcano is. And that's where a huge series of volcanic fields are. I'm thinking that energy came across in the past, and it broke there. And it compresses into the plate, compresses a magma chamber down below, causes a volcanic field up above, but that pressure transfer, that seismic force, is trying to go across the plate. That's what's happening. That's why you get an earthquake there. But denying that there's volcanoes there, man, that's asinine. And to make videos about it and try and debunk me or something for showing it when an earthquake struck there. Talk about ultimate ignorance, man. Intentional ignorance, too. I guess that's willful blindness. Now, looking at the earthquakes in California, we need to turn this down for the last day. So let's go for the 24-hour time period now. This is going to remove some of the earthquakes off the list. This is just what's moved in the last day, 0.0 and greater. So we've already talked about Washington. We've already talked about Idaho, and again, yesterday, and the earthquakes going down across over into Arizona. Again, that was all technically last night. The earthquakes today, going down along the coast, going right down and stopping at a place called Parkfield. We have a cluster east of Monterey Bay and several earthquakes now around Mount Diablo National Park. I'll get into what that all means, but first let's start with this earthquake down here to the south. This is at a place called San Ardo, but really San Ardo is right here on the San Andreas. And right next to here, over to the east, you see there's nothing marked on the USGS map, right? Well, let's go put the coordinates in for San Ardo and show you what's right next to it. Why are the earthquakes going down here and stopping? Wait till you see what's there. It's not a volcano. You'll wish it was. Hey, wait. Guys, hold on. We've got a hot spot here along the coast of California. Right in the middle of Live Oak, California. The computer filtered it out and said it wasn't anything. Said it wasn't a hot spot. We have a hot spot that appeared right in the middle of a residential area. 5 Acre Fire did not show up next to my house, so I don't know what to make of that. Looks like we're at a skate park or something. Is that somebody's house? What is that place? Wow. Again, I'm telling you, it's not like they're going to be having big fires down there. You know what I mean? But let's put the coordinates in. Go see where we go. We go to San Ardo. Told you there's something just to the east. Right over here. All of this. A place called Coalinga. They're not doing coal extraction there. That gets its name from the railroads back in the 1800s. This. Oil and gas. Lots of oil and gas drilling. Tens of thousands of drill points right along the San Andreas. Let me show you the San Andreas. Oh, it's right here. We don't have to go far. We can have it in the same shot. There we go. San Andreas. Drill points start. Earthquakes come down the San Andreas, down to where the drill points start. It's like a perforation. That's where the perforation starts. Now guess what? They drilled all the way down, around, and back up in a big letter J shape. And this is the San Andreas. They drilled right up to it. Let me show you. Again, I'm a proof guy. I'm from Missouri. Missouri. Depending on where you're from in Missouri, you're going to say it either Missouri or Missouri. We're the show me state. It's our motto. You got to show it to believe it. Nobody would believe me if I told you they drilled 1,000,000 times right along the San Andreas. You'd say, no, that's an exaggeration, Dutch. No, it's not. And they drilled right along it all the way down. That's what all these little black spots on the ground are. They look like ants on the ground at this point, but everyone's an oil well connected by tens of thousands of drill points and pipeline. Now, if it was just there, you could say, hey, it's just chance. But they did the whole mountain range. You see, this is a mountain range, right? This is what it used to look like. A mountain range. But they came in and scraped off every mountain top and put an oil well in. And it looks like sand dunes, almost, going on where they scraped off every mountaintop. And that's the whole mountain range, going all the way up to the north. So all of this is drill, back up to here, and the earthquakes come down and go into the drill points, go into those perforation points. But it transfers through. It doesn't just stop it. It doesn't absorb it. You'd think it would, but it doesn't. It goes through it like a path of least resistance. So we should see new earthquakes pop off down here at the south tip of the letter J shape of all those drill points, which I didn't even show you, but they go down here all the way down to the south tip of the valley. We should see a new set of earthquakes pop off down here, about the same size as what's coming in from the north. Let's recap. California has a line of earthquakes coming down the Nevada border that are going over to the supervolcano, spreading over to the east. We have a line of earthquakes going down from the northwest, following the edge of the craton, coming in from Montana and Idaho, but in the last day, it's mainly spread over to the east all the way to the east coast. Again, look at that spacing. It is perfect spacing on the edge of the craton. Down around the south, back up to the north. It's one of my biggest discoveries on the craton, guys. By the way, the professionals said there was never any transfer that ever happened across the craton. I showed them years worth of research, and they mocked and ridiculed me, said it was chance and coincidence, and that was 7 years ago. So, there's the line of earthquakes going across the craton edge in the last 24 hours, again, down through Texas, following our arrows perfectly. Down to the south we go, Central California, going into Southern California. So far, the earthquakes we're looking for in California have not hit. I'm looking for 5.0 range around the Bay Area, or upper 4, and I'm looking for a 5 out in the ocean. We could see 2 upper 4s in Central California going into Northern California, like I said in my last update. I'm really leaning towards a 5 out in the ocean and 4s on land. We'll see. So far, nothing except from 0s, 1s, and 2s, but I'm not let down. All those tremors. Hundreds and hundreds of tremors. Look, you're not going to move Washington and Oregon and not expect to see a new line of outbreaks go on down through California along the coast and focus in on the Bay Area in between our 2 areas that are moving. Think of this like a 2-arm scale, where on the north side of the Bay Area, you got a bunch of earthquakes, and on the south side of the Bay Area, you got a bunch of earthquakes. The spots that are getting hit, oil points, back up to volcano at Mount Diablo, and back up to another volcano where this big stack is at Clear Lake. Let me show you Mount Diablo. Let me show you Clear Lake. So, getting in here, Mount Diablo State Park, over here next to North Peak. Let me see if I can get one of the names on there. I don't know if it's going to come up. Mount Diablo State Park. They used to say it wasn't a volcano, guys, until we got into it with the professionals out on the West Coast and pushed the case about the tuftage up on top. And you see, I found documents from the 1950s and 60s that contradicted what the media was saying. You got to understand what happened, though. A swarm of thousands of earthquakes struck right below all of this a few years ago. I documented it, went and did deep research, found Google books from the 1950s and 60s and started reading them, and they found volcanic tuftage up on top of Mount Diablo. And that information somehow got buried. And the media came out and said the earthquake swarm that happened at Mount Diablo, and people thought the name Diablo meant something with volcano, that it wasn't a volcano at all, ever, and that there was no relation between volcanoes and earthquakes. They said this in the media. No relation between volcanoes and earthquakes. And no volcano. They doubled down on stupid. And I corrected it. And I proved it. And I provided the data, and people had to accept it. And they said, well,
It must have formed back when it was down underneath the ocean floor, and to call it a volcano now is not really to call it a volcano. Yes, there is tuftage on top, but that sea floor tuftage just rose over time, you say, Don. We can't be wrong. And they closed the book. Okay, that's Mount Diablo, where this little stack of quakes. But up on the north side, this is indisputable. The geysers of California. So while they're, going to try and deny that I bet they were worried about property values going down or something around Mount Diablo. But up on the north side, here, they're not worried about property values. This is a volcanic field. And lo and behold, we have a hot spot there that the computer's filtering out, says it doesn't know what to make of it. Well, look what's right here where the hot spots are coming up and being detected. Geothermal turbines. The geothermal turbines are turned by steam, and the steam is generated from the heat in the ground, and they pump sewage down into the ground, human sewage, steam it off, get the steam, put it back up through the turbines. And we got a hot spot right there at Clear Lake Volcanic Field, Mount Canocte. Can't ignore it. Computer says it's nothing. No biggie. No biggie. What are you paying attention to that for, Dutch? What does it mean? Well, I don't know. I guess we're going to have to look into it and try and figure out what it means. Why are you looking into it? Well, I don't know what it means. The conundrum of science. Why are you looking into this? Well, I want to figure out what it means. Well, how do you know it means anything? I don't know. I got to look into what it means. It looks suspect. It looks sus. I had some kid. Hey, funny story. I go to get a pile of dirt for my wife. And I pull the Hummer back into this like little back area here in our subdivision to go get this free dirt they've got. They dredged one of the lakes a couple years ago, and we got this just awesome, super fertile dirt. And I go back in there, I drive in, I got a shovel and some stuff, and I'm digging. These kids come out. They're like probably 10 years old. And he's like, hey, what are you doing? And I'm like, he goes, I thought you were doing something sus back here. And I looked at him, I'm like, sus? Huh? Kid? How old are you? Sus? He's like, yeah, I thought something sus is going on over here. I'm like, yeah, nothing sus going on. You think I'm digging? I go, what, do you think I'm burying a body? And he goes, no, I thought you were looking for treasure. I go, kid, we live in this area called Lake Sherwood. I go, this is the Sherwood Forest, but I guarantee you there's no buried treasure in here. The only treasure is going to be a plant my wife is happy about. Anyway, funny story, doing something sus. Now, why does it matter if you're doing something sus? Well, let's go look up this earthquake. Show you something sus. Why it matters if something's sus or not. There's sus and there's not sus. This one's sus. Let's go look it up. Here's the earthquake coordinates. Cold Creek, Nevada. And first of all, any place that's called Cold Creek, Nevada is probably BS. But anyway, right northwest of Las Vegas. And we're right next to the nuclear test sites that are right here. Here's Doomtown, the famous Project Riseline, Operation Riseline, where they blew away the town on the surface. Now, all these underground nuclear test sites are the craters that you see in the ground here. And they did these from the 1950s all the way forward to the late 80s, early 90s even maybe. But this one, as of 1965, December 16th, 51 kilotons. Operation Buff, B-U-F-F, Buff. Yeah. Here's Area 51, in case you wonder a point of reference where we are. We're out here in Nevada. Area 51's right next to the nuke test site. Coincidence? Is it coincidence there's an earthquake there? They're not doing any nuke tests there now, so what's causing it? Well, the same thing that's causing the earthquakes to go down to the super volcanoes, the same thing that's causing the earthquakes to go down to the other volcanoes along the coast, follow the San Andreas, and dead end into the pumping operations. It's that standing wave. It's just trying to spread across the plate, guys. And it has. Again, one more time, last 24 hours, look at it. The only thing that's missing is the earthquake from yesterday in the middle, in between the West Coast and the Midwest, which is the one I just got done totally laughing about. The professional guy. Mr. Professional. Down to the south, Ridgecrest. The number of earthquakes has dropped off. The magnitudes have dropped off. Everything down in Ridgecrest has dropped off. It's dropped off along the coast, too, really. I mean, if you go over here, the number of earthquakes has dropped off. So, dropped off on the coast, dropped off down at Ridgecrest. That's about to flip. We're about to see a big increase. Why? We're shifting. Washington and Oregon. Looking for a new 5 out in the ocean, looking for a new near 5 down in the Bay Area, and we're looking for a spread to come down to the south, which means Ridgecrest will ultimately get hit too by the start of this next week. Wait, by the end of this coming week. So by Saturday, I should be on here issuing a warning for, or very close to Saturday, issuing a new warning for Ridgecrest. But none of that's happened yet. We're waiting for this to take place. Southern California, even the new person here that's never seen this before should be able to see the diagonal line of quakes starting up here with a 1.1, ending down here at the Mexico border with a 1.5. This is the southern arm of the San Andreas, but we branch off of it. Let me show you. And we're going to go here. Actually, hold on. Before we do that, let's go look up this lone earthquake in LA Basin, Corona, California. Corona, California, of all the places to have an earthquake to look up. I got a letter from someone here. Sent me a letter for my birthday. It said, "Happy birthday, Dutch." This is serious. This seriously happened. "Happy birthday, Dutch. Thought you might like to see this." And it's all my personal information, including my cell phone number, my soc, everything. Yeah. Corona, California. Look where we are. Well, we're at Corona, California, but we're at the NEXRAD radar station, the 750,000 watt high-power microwave tower. That's nothing to see there. But maybe on the other side over here, there might be something worth seeing. I do know that we've got a bunch of oil pumping operations that occupy this whole hillside. So we always look 6 to 10 miles because they can drill out by several miles at an angle. So how far are, let's see. It might be more than 6 to 10 miles there. I don't think so, though. That doesn't look like 6 to 10. Let's see. Linear, exactly 6. So exactly 6, pretty much on the spot. And I always look 6 to 10 because the USGS used to look 6 to 10 back in Oklahoma before they changed the state rules. Because they can drill out by, let's say they drilled out by 2 to 3 miles this way, down at an angle, down below the highway, let's say. And the earthquake is over here on a fault. Well, they're connected. This drills down below it, hydraulic pressure up underneath it. Think of a hydraulic arm, guys, and you're pushing up on the underside of something. You're pumping it full and it's rising. So earthquake right there. That's where the blue earthquake is, jumping off. The rest of these are in a diagonal line, aren't they? Once they get down to the lake, or, well, Salton Sea, not a lake, a sea, whatever you want to call it. We go in a diagonal line this way, and you can follow the mountains that way, can't you? And where do we go? There we are. We're west of Salton Sea, where there are 2 more hot spots down here next to our other geothermal pumping operation. This is where the boiling mud pits are. And the computer says, what does the computer say? It's filtering them out. It says it's nothing. The boiling mud pots are steaming. The satellites picking it up from space. Oh, it's nothing. Sure. I would say it means earthquake, plate shifting, heat release, electric energy coming up, electromagnetic energy coming up out of the plate, being detected by the satellite up in space as heat. Or similar. Line of quakes following this line, which is the San Andreas. Once we get west of Salton Sea, take a gander. Take a look. West of Salton Sea, we have the thin red line. Plate boundary is the thick red line. The earthquakes are coming down the plate boundary, stopping at the pumping points, picking back up down beyond the pumping points, and going down and spreading out across the western side of Salton Sea. Well, this is the Elsinore Fault here, and this is the San Jacinto Fault, if I've got that right. Yeah, San Jacinto. So these two start to move. It's a path of least resistance. Instead of going around the bend of the plate, it goes straight across the cracks in the plate at that point. It's shallow. It's not deep. These are all very shallow. So shallow, it's taking a path of least resistance, just going straight across. And it goes back up here where it's open. But you got to remember, this open area, quote unquote, is all drilled, giant letter J shape. And it's drilled out here off the coast, too, with offshore platforms. And it's drilled right here at Ventura, going to offshore platforms. Or wait, right here, going to offshore platforms. So it's drilled all across this open, quote-unquote, area where we don't have any earthquakes right now. But it's all caused by the plate shifting up in the northwest, where I'm watching for a 5 out in the ocean, 5 down in the Bay Area, or near 5, upper 4,
Southern California, Ridgecrest, we could just warn you now that Ridgecrest should also get hit in between now and the end of this coming weekend, which is the next 6 days. Okay, let's get back into it. Let's go back and look at the western part of the West Pacific. Hold on one second. Let's get the feed turned on here proper. Last 7 days worth of earthquakes. It's going to take a minute to refresh. There we go. Okay, so now this is the last 7 days. It's a lot of activity. The bigger earthquake struck at the start of the week, the 6s. We went down to 4s. Then we came back up to 5s. And I'm looking for this to take the next step higher. So I haven't issued a new forecast for the West Pacific, but where our rings overlap and where our open areas are where we watch for new, larger earthquakes to take place. So in the West Pacific, I have to warn right here, if we go around the bend of the plate, I have to warn right in the middle of it, that's Bali and Java. Now, on the east side of Bali and Java, Luatolo volcano is erupting over here, kind of right where these ring edges come out to, next to East Timor. And all the way up here, Mount Sinabung is erupting. So the halfway point between those two is Java, if we go around the bend of the plate, between the volcanoes. So we're between volcanoes, and we're between a bunch of 5s. That means something bigger is coming in the middle. Java, Bali, get ready for it. It should be in the upper 5, low 6 range. The 2 volcanoes plus all these 5s should be in the 6. Up to the north, we have a huge cluster. This is off the coast of Japan. So I'm going to warn off the coast, right along the coast of South Japan, right where our letter D is. And this could go next to Kyushu, but you see where all 3 sets of 5s overlap? I would take the 5.8 plus the 5.4. That equals 5.9. I would take the 5.3 added in. That equals 6.0. I would take the 5.6 up to the north. It would be 6.056. We could round it up to a 6.1. So let's warn for a 6 in Japan, 6 to 6.1-ish, where the rings overlap next few days. Up to the north, 2 open areas, or 2 overlap points. One here, you see obviously all the rings overlap on the south side. And right here on the north side. Well, where the rings overlap on the north side is Mount Ebeko, which is erupting. Ebeko? Erupting. How about that? Right there where all the rings are overlapping. So, new earthquake is due here. And the earthquake should be the combined total of what's on all sides. 5.6 plus 5.1 equals 5.71. Add in the 4s in the middle, doesn't really raise it that much. We're looking for something in the upper 5-ish level to strike up here on the north side where the rings overlap. Okay. Over to the west, let's go ahead and warn. So let's go, like I said at the start of the update, we have to watch right here. It's pretty obvious. We go around, over, up, back, down, and around. That's the shape of the red line plate boundary I've already showed you 1,000 times. Middle point, the combined total between the two, this takes us to near 6. 5.8 plus 5.2 equals 5.92. And then add in all these other 4s, takes us right to near 6. Europe, over to the west, where our rings overlap in eastern Turkey, where our rings overlap at the Aegean. I already warned, or not the Aegean, the Adriatic, right here. Okay, that's an update if I ever did one. Man, I need to do more. I will. I'll be doing more. You can bet on it as things pick up. The only thing I didn't touch on, the deep earthquake in South America, right here on our letter D. Deep 4.6 down below Argentina, right at the Argentina-Bolivia-Chile border region. Deep 4.6 means shallow 5.6, most likely coming in the next few days. Look where the rings overlap. That's where we watch North Chile for a 5.6. That's due to the deep earthquake down below it. Okay? That's the only addition that I've got to it. I didn't cover, seismically speaking, what to look for in the Caribbean. But then again, what's the point? If I'm going to issue a warning for a 6, and a 6 gets reported by the computer, and then they cancel it off the list again as a mistake, and that's the 18th time that I've issued a warning for a 6.0 plus earthquake, and they say it's a mistake when it strikes out in the ocean or something, right? I don't know. I don't know what to say. So I don't think I'm going to issue a warning for it. I think I'm just going to watch, see what happens. Same with down in South America. Look at our big open area. Well, We're going to watch. I'm not going to directly issue a warning for it yet. We have 2 volcanoes going in here. That's Sanjay and Reventador. But ultimately, same thing that's going on the rest of the plate. If we're at upper 5 level now, well, you know what? I should just issue a warning for it now. If we're at upper 5 level now, then it should be at an upper 5 level here at the middle point between the 2 volcanoes and the earthquakes. That's Ecuador, North Peru, upper 5. Eastern Caribbean should be seeing it. We should see an upper 5 to maybe even bigger. We might even see a 6 pop off over here on the east side of the Eastern Caribbean very soon in the next few days. But La Soufriere keeps going. So La Soufriere volcanic eruption. We've got earthquakes over here spread out across all of Central America. It's all going to pool up and come over to the east. The volcanic eruptions and the earthquakes pool up together with seismic total, if you will. And that's where our bigger earthquake will come on the east side of the Caribbean by the end of the week as well. At the end of the week, so by Sunday, I guess, of this coming week, 7 days from now, we'll probably be seeing activity out here on the letter X's between the end of the week, okay? Between now and the end of the week, most likely out at the end of the week. I will be back. I would urge you all to listen to my voice now. Have an earthquake plan. Or at least think about what you'll do if an earthquake hits. How about that? Just think about it. If an earthquake hits, where are you going to go? I've got a wooden desk here I'm going to take shelter underneath. I'm going to try and get my cats, but if I can't, they're going to scurry and go someplace, probably under a couch or a bed or something. Now, that's not going to support the falling weight of a structure, will it? A desk or a bed. So you've got to know your structure. You got to know what kind of building you're in. Stone stack is different than a frame house, obviously. A concrete structure is different than a stone stack structure. Reinforced concrete is different than regular concrete. So again, you know your area, you know your building, you know whether or not it'll probably withstand a large earthquake or not. But if you're iffy about it, I would recommend having a place to go outside immediately if you have to exit the building. But the USGS says don't exit. But they also used to tell us to go stand under a doorway, didn't they? I know that somebody in the professional world used to tell us to go stand under doorways. Now they tell us that's an old wives' tale based upon a picture from the 1800s of a building with a door frame standing. Yeah, they say now don't stand under a door frame. Okay, so you probably would want an area at least to gather outside after an earthquake. After a big earthquake hits, you might have natural gas going in your house. You have to go outside anyway to shut the gas off, maybe down in the basement, maybe somewhere else. But you need a pre-designated area, whether it's around the house or outside the house, where you can meet with the people you know after any kind of event takes place. Okay? So don't be scared. You need to be prepared. You need to know your areas. You need to know your house. You need to know your business. You need no. Now, the emergency kit. This is something that most people don't take the time to do. And it's usually made of stuff that's already in your house, guys. So like an extra flashlight, extra battery. Don't rely on your mobile phone flashlight. You're going to need your mobile phone maybe for text communication. You can't make a phone call, cell phone towers down, or limited data is, too many people are on at once. Well, you might be able to get a text message off and not get a phone call off. And you need to hold that. You need to hold your battery. You also need a way to charge it. So maybe a little portable solar panel, one of those little pocket-sized ones they sell at the store now. Something that you can use, again, to charge your mobile devices. No-brainer. Also, first aid sanitation. In this day and age, with everything we went through in the last year, first aid and sanitation, at the sanitation part, you should have covered at this point. The first aid, I don't know. People sometimes have it. You're supposed to have Band-Aids and all that good stuff at your house. Have it into an emergency kit. Extra set of keys. Oh, my goodness. Extra set of keys, extra debit card, extra ID, or at least the stuff you need to get the ID. The extra paperwork kind of stuff, put it into a folder, waterproof, have it into the bag. The extra set of keys thing will probably come in handy anyways. When you lose your keys somewhere at some point in the next few years, it'll probably happen at some point, and you'll be walking around and you say, I've got an extra set in the emergency kit. I know right where it is, and that's the final point on this. You need to put it someplace easily accessible. You don't want it packed at the top of a closet far away in the basement. You want it somewhere, or if you have a basement, you want it somewhere easily accessible by you and the others in your household or in your business, okay?
I know it sounds preachy, and I've got it down pat. I've done this for 9 years, guys. I've got the whole thing memorized. But I'm serious about it. I want you to do it. And if you don't, well, that's on you. But if you do, you'll be so much better off than the other people around you who are all just too cool or too busy or too know-it-all-ish to do it. And that is all I have for you. I hope you're doing well. Yeah, a solar charger, definitely. Again, people, again, in the chat room are blowing it away. By the way, if you're watching on YouTube, you're watching a pre-recorded event. This is all done live before an audience on Twitch. How many people are in there? I don't even know. I'd have to go over and check. I don't have a live counter on the screen anymore. I know it's in the several hundred range every time I get on, but word up and much love to everybody who watches. Let's go see. About 400 people. That's good. Now, on Twitch, you can watch for free. If you're on YouTube, guys, we are streaming 24/7 over on Twitch. You know why? I used to try to stream on YouTube 24/7. They sent me a notice about 24-hour streaming and said that blah, 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 a controversial earthquake, blah. And that was at the start of it. I kept trying to go, and they limited me down to 50 live viewers out of three. At the time, I had 300,000 subscribers. Now I'm at 500. But at the time, a couple years ago, they limited me down to 50 live viewers per broadcast. It was ridiculous. And I came over to Twitch that night after they limited me to 50 for the final time, and I started out on Twitch with no subscribers or anything in the multiple hundred viewers range. You want to talk about being limited and not allowed to be streaming on YouTube? I don't know why either. It was the biggest freak out over me showing earthquakes and telling you where I think they're going to hit. Everybody shit themselves. Oh, dang it. I just got us on PG-13. Damn. I was doing so good. Well. Well, kids. Well, this is the earthquake guy. I'm here in Missouri. And we're real high quality update here. Oh, my goodness. That was my chair, by the way. You hear the squeak in the background. You're probably thinking, okay. Oh, what a way to end it. Oh. That's like nosediving. They're like, look at the runner. He's got such great form. I'm running around the track. I'm like, oh, I've got this. I'm doing a victory lap. I'm like waving my hands. And next thing you know, face plant. Boom. And we'll leave it at that, guys. Word up. Much love. I'll be back if anything else goes down.